Hello, this is a video on restriction enzymes, primarily for my AP biology class in preparation for completion of your worksheet on biotechnology and restriction enzymes. Okay, so we're going to go through what restriction enzymes are and then look at a couple of examples. Okay, first of all, restriction enzymes, they're naturally occurring. Oh, before I continue, I have my two viruses with me. Okay, big virus and little virus, they'll help keep me company here. But anyway, restriction enzymes are naturally found in bacteria. They're defense against bacteriophage infection. Okay, so here's a bacteria, and here's bacteriophage, and they infect, but it's a defense. It actually breaks down the bacteriophage DNA that gets injected. So go back and review how both the lytic and lysogenic life cycle for bacteriophages. Okay, make sure you know that well. But anyway, looking at restriction enzymes. Restriction enzymes come from bacteria. They're actually named from that bacteria. So, for instance, restriction enzyme EcoR1 comes from E. coli, and they act as molecular scissors, and they cut DNA at a specific nucleotide sequence of restriction sites. Say cutting the backbone. So if we look here, okay, there are 5 different restriction enzymes listed. Okay, this one is ALU1, HAE3, BAMH1, HINDI3, and EcoR1. And notice that they recognize different restriction enzyme sites. Okay, so for instance, ALU1 recognizes the sequence AGCT and cuts there. EcoR1 recognizes GAATTC and cuts in a diagonal pattern. This is a blunt cutter. Okay, so look at the PowerPoint under biotechnology resources for what blunt cutter means. It cuts straight across. And here, EcoR1 gives what's called sticky ends. Okay, so it's a single-stranded DNA overhang. We'll see more about that in just a little bit. So, to look at how restriction enzymes work, okay, viruses have to move for just a bit. And we'll take a look at how they work. So with sticky ends, the unpaired bases of the sticky ends can bond with complementary bases. And then we seal that with DNA ligase. So here we have 2 different pieces of DNA, one from one species, let's say it's from bacteria, and this is another species, let's say it's from human, and they cut with the same restriction enzyme. In this case, EcoR1, so it cuts GAATTC and cuts here, and we end up with 2 sticky ends. So you see it's the 5' and 3' overhangs are complementary here. And then we can seal them back together with an enzyme DNA ligase. Okay, we saw that with DNA replication. But anyway, since the ends are complementary, they will seal back together. So let's cut this piece here with EcoR1. Okay, so cutting, we look here, and we scan along and find, we're looking for the sequence 5' GAATTC, 3'. So we're cutting with EcoR1. So let's scan along here. So GAATTC. Okay, well here's 1. GAATTC. So we cut here. And let's see if there's any more. Okay. So there's no more EcoR1 sites. So how many fragments do we end up with from this? Well, we have a short one here, so that's 1 fragment. And here's another fragment here. So we end up with 2 fragments of DNA. Now let's try another restriction enzyme. In this case, it's going to be ALU1. Okay, so ALU1 cuts at the site AGCT. Okay, so ALU1, I'll do this in a different color, cuts 5' AGCT. Okay, so let's find that. A, G, C, T. A, G, C, T. Nope, it doesn't cut. So that won't cut in there. So ALU1 will not cut in that sequence of DNA. EcoR1 does. It cuts it into two fragments, here and here, but ALU1 does not. Okay, so restriction enzymes recognize a specific sequence of DNA and cut there. Okay, so work on the restriction enzyme practice sheet, worksheet, and turn that in. That is due by Monday. Hope you're all well. Say bye to the viruses.